Okay, so part 7. This is actually the final part of Introduction to Programming. So one more week to go, and then we will have a 1 week break before the advanced course starts on October 13th, so in 2 weeks. And last week we talked about using external files, about reading files, about writing files, and then about some specific file types like CSV files, and how we can manipulate those. That's actually something we're going to talk about little more today of. And then at the end of last week, we also talked about validating inputs, about exceptions in Python, and about a little bit about the global and local variables. And if you take a look at the feedback from last week, there were some problems with the test on server, and there was a lot of feedback about this, which is of course good. And there was also a lot of messages about this in Discord. This should be fixed now. And I think that at least they promised the people maintaining the server, promised that when they fix the problem, they rerun all the submissions, so you should have gotten the points even if those were missing. But please check this. And so if you had a problem which worked perfectly locally and you didn't get points for that, then please check that you got the points. And if you didn't, then resubmit and see that you get the points. And if you don't, then let us know or let me know. So sorry about this. This was an unfortunate problem. This was due to some changes made in the server, and they didn't realize that it broke some of the programming exercises, not all of them, but a couple of them. And but it should be fixed now. And then other things about feedback. Yeah, okay, they seem to be working fine now, which is great. And they did actually finally fix them rather quickly, or did take them something like 24 hours, but still rather quickly. It was a big problem, so I'm great, glad they did it. About some of the feedback, some other feedback. For some reason, it seems that file writing, a lot of people considered that more difficult than reading. We maybe spend more time on things about reading. I think with file writing, you're probably referring to writing CSV files, I think, because writing just text like individual lines shouldn't be that difficult. You have a single statement, single method for that write method. But forming those CSV files can definitely be a bit more complicated. And I think it probably can be a more complicated task than reading data from files. And try except is something that a lot of people consider sort of a difficult, and it does require some practice. The difficult thing about try except is trying to figure out that what you should include in the try block, because that's not always obvious, and that might have a lot of effects on your program, or whether you just include the statement that may throw an error, or whether you include some statements following that statement. And sometimes you need to do that, and sometimes you shouldn't do that, and it really depends on what you're doing. And that's a really sort of common source of errors as well. So if you find it difficult, then you're not alone. And again, it's something that you just need to practice. Then there was a question, I think this was a good question, why we can't do something like this. This was probably related to exercise with the train stations where you need to find the route between two stations or something like that. But why can't you pick, or so if I have a different example, if I have, let's say I have a list of strings. It's too small, might be. And you want to take want to take the first letter of each name and do something with them. So why can't we do this? And then do something with that one. And the reason for this one, why this doesn't work, is of course that you need to provide a variable in here where these names are assigned one at a time. And this one is not a variable, it's instead, it refers to a first item in an object referenced by this variable. So although it seems to be a variable, it isn't a variable in that sense. It isn't something where you can assign. Well, you can assign something into this if it is a list where the item is. But in basically what you need to do is you assign these into variables, and then you can pick the first item from those. I think that was a good question. It's something I've been sort of not in this not exactly like this, but I've been trying to do something similar sort of before with or wondering if you can do it with list comprehensions, and of course you can. And that was a good question, I think. There were some typos in the material. I fixed actually some typos yesterday. I actually spent some time fixing some typos. If you come up with anything, please write them in the feedback or send me a message or whatever. If you have time, I can fix them. We can fix them quite quickly if we know that they are there. But I think that most of them should be fixed, but there are definitely some typos remaining here and there. So if there are, please let me know. And then there was a question that is the for statement the only way to read a file, and we actually covered some other means for reading files last week. Say that we have what was there was names. No. Well, names.txt, for example, open in read mode. And the typical way is to do something like for line in file. And I sort of prefer this one because it's usually sort of logical to handle the file one line at a time. It also means that even if you're working with a longer file, it preserves memory because you don't need to load the entire file in the memory all at once and so on. But there are ways to read it. You can read the entire contents with the read statement, or there's a read line statement, which basically gives you all the lines in a file as a list, meaning that after this one, each item in a line, this computer is really slow for some reason. Each item in a file is now or each line in a file is now an item in this list, which is useful for some occasions. For example, if you need to iterate through that file several times and do something each time, or if you need to write some of these lines into another file, then this might be easier or something like that. And there are other ways to do this, but most of the time I sort of prefer using the for line in file for obvious reasons. It's also easy because that works with so many things in Python. You can use it with lists or dictionaries or strings or tuples or a lot of other things as well. You can also write your own structures that you can iterate through, which we're going to talk about in the advanced course. And it's so easy. If you just remember that for something in something construct, you can do a lot of things in Python already. But there are other methods for reading files as well. Okay, good feedback, good questions. I think these were the most common ones I came up with. Again, remember to give the feedback. Even if this is like the final part of introductory course, please provide the feedback, because I will check all the feedback after the course at some point, and then this feedback is used to do modifications for the course in the upcoming years. Okay, today we're going to talk about mainly about modules. And another thing about programming is that there are already a lot of things you know how to do, and then there are a lot of things you don't need to do yourself. And Python comes up with something called the standard library, which contains several useful modules. So you don't need to download anything other than the standard installation of Python, and you already have a bunch of useful modules which you can use to perform things that might be complicated to do yourself, or at least you can save some time by using those existing modules. And we've been using some modules before. For example, in the very first week, I think we used the square root module to calculate square root, which is something that's actually quite difficult to implement yourself. So if you try to calculate the square root by just performing simple mathematical operations, you can see that it is actually quite complicated operation. But it's quite easy with the square root module. And now there are several ways to use. This isn't finished. Okay, to use modules, and the most basic one is to just import the whole module. So if you want to use the math module, we just state that import math. And the thing is that you need to, or in Python you don't, the syntax allows you to use these import statements wherever in your program, but it's a good programming convention to list all the imports in the beginning of your program. So before you define any functions or anything like that, you have all the import statements you're going to use in your program. And the reason for this is that when you take a look at the program code later, or someone else takes a look at your program code, it's easy to see which modules you're using in your program. Okay. So once we have imported the math module, and what happens in this when we use the import statements is Python. Yeah, it is possible that two different functions with same name can exist in different modules. And for that reason, it's also important that we import these modules in the beginning of the program. So what happens when we import a module is that Python creates an access to that module, all the operations in that module. And after this one, we can then use the operations in that module. So meaning that if you want to calculate the square root of something, we can type in math and then use the square root routine and then calculate the square root of 16, which should be 4. It's actually going to be 4.0 because the result is a floating point number as seen in there. And this is like the most, I think, the most common way to, well, probably the most common way to use modules, but the idea that we import the entire model. And now if you take a look at the math module, and the easiest way to see what's in it is, I think, just to, when you type in code in VS Code, just type into module name, then type in the dot, and then VS Code gives you this tooltip or this listing of all the operations in this module, so that you can then scroll through it and see, you can see that there are, and for this math model, this is actually quite simple if you're familiar with math, because a lot of these are like cosine, cosine, and so on. Some of them are definitely more difficult to interpret. Yeah, but you can at least take a quick look at what's in there and maybe find what you're looking for. If not, then you can check the documentation, and again, Google is your friend. Just Google Python math module or something, and you get a listing with detailed listing of what these instructions or what these operations are and what they do and so on. So we can use whatever operations. So if we want to calculate the power of x to y, we can do something like 2 to 9, for example, and then it calculates the result of 2 to 9, which is 512. And the results of I think most of the math module operations return a floating point number so that they are compatible with each other. So you can chain these as many times as you, or as many operations as you wish. So this is like the easiest way to import something, or at least shortest way. Another way is to import individual operations. So let's say that you want to use exactly you know that you're going to need a couple of operations from math module. So you can state that from math import, and then you list the operations you're going to need, something like sqrt and pow, and let's have the cosine operation as well. And after this one, the difference is that now you can use these operations without providing the module name. So now I can say something like result equals, and instead of typing math.sqrt, I can just type in sqrt and calculate that on, or I can calculate the power of 8 or square of 8 to second 8 by like this, or something like I can use the cosine operation as well without providing the math model. So this makes it easier for some occasions. Now, a lot of people prefer not doing this, but instead just stating that import math and then using the math dot something. Why do you think that is? There are, for example, a lot of these programming projects, or if you're writing code in as a part of your job, then there are in larger projects there are often requirements stating that you should do all your imports like this. For example, I've been using this example before, but for example, Google's Python programming conventions, at least at some point, stated that whenever you're importing something, you should import a module like this and not individual operations like this. What might be the reason? Why can this be considered a worse practice than the first one? Is the question I'm asking here. The answer actually already is in the chat window, although it was given for the thing prior, but that is mainly the reason. That is one good answer to this one. And the reason for this one is that when we do it like this, you don't immediately see, when you look at line 5, for example, there's no connection between the SQRT model and the math model in this line. So you need to scroll back to beginning of the program to see that, okay, we're using this operation from this module. And in this case, this is quite obvious because most of you probably remember that the square root operation is from the math module, but it could be that the name doesn't always imply on what module it was imported from, and it is perfectly possible that there are two similarly named routines in different modules. So if you're doing it like this, then you don't know. It's difficult to see if you don't remember that where this function came from. Even the tooltip doesn't say that it comes from the module math. So if you do it like this, so you just import the module and then you type in the math.sqrt or the math.pow, then it's obvious that you're using these operations from the math module. And it's also easier to check the documentation for those operations to how they work. And especially if your program is doing something you're not expecting, then it's easy to see, easy to find out what might be the reason for that. So this one, I don't know. In some occasions, I actually do use this one myself, and I think it's okay to use this one as well, especially with some specific models. I will show an example in a little while. But if you always do it like this, then this should be okay in all occasions, I think, because then it's what it does. It makes the code more easy to debug and easy to see where the operations come from. Then there's one final way, which is using this wildcard character, which states that you're importing all possible operations from a module. So we can state something like from math import an asterisk, and this now means that we have access to all operations in the math module, and now we can use, for example, the power operation like this. Now the problem, and this is problematic, and I would sort of recommend not doing this, because now there's no any connection in the entire code between this power operation and this. So only way to find out where this operation come from is to read the documentation of the math module, meaning that you need to go outside this program code to know what it does. So although this is possible, please don't use this. I think it's important to know what this does, because it's sometimes used in Python programs. And if you take a look at the code written by someone else, and you see this, it's important to know that it means that you're importing all operations from this module, but try to avoid it yourself, because it can make your code really difficult to understand. And writing code that's easy to understand is a really an important skill. And I think that's like one of the most important skills a programmer could have. Even if you don't know how to use all the like fancy operations and your code isn't like the best performing or anything like that, but if you can write code that other people can understand and maybe edit or something, that's a great skill. That's actually what makes great programmers, in my opinion. Okay, Then let's see. Okay, one more thing. Easy way also to see the contents of a module is to use the dir statement. So if you have imported the math module and you want to see what's inside the math module, you can output this statement. It actually gives you all the operations in that module as a list. This usually isn't that useful in programs, but what you can do is you can use it in your console, so you can. Okay, something really strange is happening. Okay, Python maybe. Oh, okay, yeah. Just update it to. No, it wasn't just, but yeah. Update it to Windows 11 at some point, and some things are working strangely. But for example, in Python shell, if you import the math model, in this case, you may want to see like the directory of the math module to see what operations there are and so on. So this makes it easier. Easier maybe to locate the specific operation you're looking for in a module or something. So if you remember that there is or if you're quite certain that there is an operation in this module I can use to do something, but you can't remember the name, then you can take this list. This might also be useful in some other occasions, especially when you're, for example, trying to do something with the code from another module, something specific, then you can, for example, iterate through this and do something that's a bit more advanced, definitely. Okay, then let's take a look at some of these modules that come up with Python. I've just picked up some as examples, but let's see some that are definitely useful. And let's start with the random module. And the idea of a random module is that we can use it to generate something called the pseudo-random numbers, or basically pseudo-random numbers, which can then be used for a lot of different occasions. And the idea of a pseudo-random number is that it's sort of a random number, but it isn't a truly random number. And the reason it can't be truly random is that computers work in ways that can be predicted. And if you want to generate truly random numbers with a computer, you need to use like an external source for that one. And I know applications that use something like a background noise of a location or like the background radiation, because that's also something that varies quite a lot, and it can be used to generate truly random numbers, or at least like I guess somehow something could predict the radiation, but that's really complicated. But the pseudo-random numbers are random enough for a lot of occasions, for most occasions. And the random numbers can be used for different things. Games are, of course, one like important thing. If you're writing whatever game, you typically want to have some kind of randomness in there. You could be doing something simple like a card game or a game with dice or something like that. It doesn't need to be simple, but with simple randomness. So you can, for example, generate like a function that throws dice and gives you a random number between 1 and 6. So let's do that first. Something like this, for example, and then another reasons to use randomness. There are, for example, when you're testing your program whether it works. When you've written a function and you want to see if it works, you can test it with some random values defined between some specific like between some specific values to see if your function actually works as intended. Randomness is also used in data security in cryptographics, when you're in a lot of cryptographics crypto algorithms, when you're use some kind of random values and so on and so on. So let's try this. So the dice value should return a random value between 1 and 6, and we can do it by using operation called randint from the random model. It's shortened for random integer, and it gives you a random value between A and B as you can see in the tooltip, and it also said it includes both endpoints. So if we return, or if you call it with arguments 1 and 6, then it should provide us with a random value between 1 and 6, random integer between 1 and 6, so 1, 2, 3, 4, 5, or 6. So let's try it out. Something like this, and now it should give us, sorry, I forgot to exit the Python shell. Okay, let's see. I broke my Python once and for all. This seems interesting. Let's see what happens. Okay, so here we are. I think I need to replace this computer at some point quite soon. It's starting to run maybe really slowly. Okay, so it gave us 4, and if we re-execute the program, it gave us another 4. It should, well, 4 is a random value between 1 and 6. So maybe if I run it several times, now it was 5. If I provide like 10 values, 10 random values. I don't know have you talked about this using this underscore as a variable name? Did I mention it at some point? Okay, the idea of this one is that this is a variable name. This is an acceptable variable name in Python, because in Python you can use, in variable names, as you can remember, you can use letters and numbers and underscore character, and then the variable name needs to begin with a character or a letter or an underscore character. So this one is a valid variable name. But the idea of using this one as a variable name is to note that this is a variable that we are not using for anything. And for example, when we're doing something like using this for in range statement to repeat something, but we don't actually use the index for anything, or this number generated value or variable for anything, you can use underscore to note that, let's like note for yourself or other programmers that this variable is not supposed to be used for anything. Okay, so now we get 10 random values. And the computer says yes, so these are random values between 1 and 6. And as I said, the pseudo-random numbers are random enough for almost all occasions. If you're doing some really serious cryptographic algorithms, then it might be that they are not random enough, but most of the time they are fine. And there are some specifications for random values, and one of them is that they should be sort of evenly distributed, meaning that if I pick a random value between 1 and 6, then all of those values are equally likely. And we can test it by creating a dictionary. Do something like dictionary called values, and then let's generate something like 10,000 random values by calling this dice value method, and then let's do it like this. So the idea of a dictionary is store the number of times each of these results occurred. So we're saying that value is increased by 1. So now when we draw the dice and if the result is 1, then we increase the number of ones by 1. Or if the result was 4, then we increase the number of fours by 1. And then we can do it like this. So let's see what it does. It shouldn't take too long, even if the computer is horribly slow. Hopefully it doesn't. So now when you take a look at all these numbers, all these different results between 1 and 6, different dice results, you can see that the amount of generated for each, that they are quite close to each other. By rerunning it, they still should be the same. So it seems that they all seem to be equally likely. There are a bit more ones in this rerun than there were, for example, fours, but that they are not too far from each other. And if you increase the number of dice throws, then the numbers will get closer to each other, at least like in, not in absolute scale, but in relative scale. So it should be random enough. What else we can do with the random is there are other useful methods for that one. You can, for example, you can pick an item, random item from a list. So if you have a list of names, for example, let's do it like this. Easy way to generate a list of strings like names. Hardest part is to come up with the names, but just split the string by using space as the limiter. Then you have a list of names. I think it's easier to write it like this than by writing all the quotas and commas in between the items. So now if you want to come up with a random name from a list, well, let's do it like 5 times again. We can use the choice method. In the random module, and what it does, it picks a random item from the given list. So now it gives us a five names. It can repeat certain names, of course, because each time it picks a random item from a list. If you want to come up with unique items, let's say that you want to create like a group of 3 out of this sample, and then when you create a group of 3 people, you don't want to repeat any person more than once, so you can use method sample from random, and let's see if I remember it correctly. I think I do. So now it gives you as a list a sample of 3 persons from, and now it doesn't repeat the same person twice, meaning that each group now contains, or all the persons in a single group are now individual or unique items. Of course, when we do it this 5 times now, there are names repeating in this one. When you pick a sample out of a list, the number of items in that sample or in that generated list cannot be higher than the number of items in the list. Of course, that's an error, and that's of course logical, because if you have a list of 5 items and you try to generate a sample with the size of 6 from that list, then it's not possible because you can't do that. There are some other useful items in the random as well. I don't know if I remember. The shuffle one is definitely useful. So we have that list of names, and you want to rearrange them into random order. You can do the random.shuffle and names, and then when we output the list of names, you can see that it's now in random order. So the first one, this is like the original order, and then the second one is the one shuffled. And this is again very useful in, for example, in games. You can have a list of playing cards stored as tuples in the list, and then when you want to shuffle that deck of cards, you can just use random shuffle to come up with the random order of items. You can do it with other means as well, but using shuffle is probably the easiest way to do it. Again, if you want to take a look at other operations in the random module, you can just take a look at the Python documentation. And of course, you can again type into dot and see what there are. But I think that the choice and shuffle and sample and rand int are probably the most common ones. And then there are these operations you don't really need that often, but that might be useful for if you're doing something more advanced. Okay. Then another And I think random module is a good example of a module which you good example of a case where you want to use an external model, because writing something like that yourself is possible, but there's really no point. It's quite complicated to come up with true randomness or true pseudo randomness. So it's a good idea to use the existing model. Another example is and this can be a little surprising, is that whenever you're handling times and dates, it's again a good idea to use the standard library for this one. And the reason is that there are so many exceptions and small rules with times and dates. Something like things like leap years are a common example. We had an exercise about calculating whether a year is a leap year. But that makes things like, if you want to calculate by yourself that how many days there are between two dates, then you need to consider that there might be a leap year, and also the fact that different months have different amounts of time, days, and so on, can make things complicated. And then there are some of these really difficult to predict rules like leap seconds and all that stuff. So instead of trying to do it yourself, just utilize the standard library. And for this one, we have a library called datetime and an object called datetime. And now this is a good example of a case where I think it's a good idea to state that from datetime import datetime. So now the class datetime is included in the library datetime, meaning that if you only import datetime like this, then whenever you want to use the object or class, you need to type datetime dot datetime, which is really annoying and doesn't really make your code any more readable, in my opinion. So in this case, I think it's perfectly fine to use this from module import routine. And what we can use the datetime for is to create objects that model a specific time. So for example, if we want to create the object with the current time, we can use the now method in the datetime class. And now if we output the method now, or the object now, it now displays the current time. So it's 16th of October 2025, and it's 10:54 and 6 seconds, and then a lot of decimals after that one. Is that like a microseconds or I think, yeah. So this now creates a datetime object for the time now, which is useful in a lot of occasions. For example, you may have a program you're running and you want to see how long it takes to execute. You can do this with other means as well, but something like that. You can also create other datetime objects. So we can do something like later, and then in this case, we provide the values needed. So we can provide the year, and let's say that we are interested in November and 15th of November, and then you can provide as many. So you need to provide the year, the month, and the day. If you want, you can also provide hour and minute and second and microsecond and so on. But let's say that we only want to create an object for a date, and then it defaults to midnight. So if we output the later object, it now outputs 2025, 11:15, and then at midnight at that day. Okay, so what we can do with these datetime objects once we created these are now, for example, we can compare this quite easily just by using Python standard comparison operators. So we can state that if later is larger than now, and this is true because this later, if a date happens after another date, then that date is considered larger than that another date, meaning that we can compare these quite easily. So if you have two datetime objects, you can check which one is larger, like this. You can also subtract datetime objects from other datetime objects, meaning that we can do something like this. So subtract now from later, and we can see that it's 29 days and 13 hours between now and 15th of November this year. So this is all, of course, also useful. If you're only interested in the days between two times, you can get that field from that object. So now I'm going to say it's 29 dates between November 15 or now. And this subtraction returns something called the time delta object. So let's import that one as well. And this is time delta object is great because, or useful. Well, it can also be great, but definitely useful because we can do something like, let's say, And now when we created that time delta object, which now represents exactly or not exactly 2 years, but basically like 2 years, 365 times 2, which is, well, we can do it like this. That we can then use this time delta object to add it to a date object, datetime object. So we can say something like now plus 2 years. And now if we, well, missing an assignment. And now if we take a look at the later, we can see what date happens in exactly 2 years from now. So it's going to be 16th of October in 2027. So this one also takes care of all the leap years and so on. So if I try to look like 8 years forward, and if I take a look at the date 8 years from now, it isn't 16th of October in 2033 because there are 2 leap years between us. So it's actually going to be 14th of October in 2033. So if we take 8 times 365 days from now. So you hopefully get the point that whenever you want to do this kind of date manipulation or comparison or storing dates or times or anything like that, please use one of these modules provided by this or provided in the standard library, like the datetime, which I think is useful for most occasions. And even if you're doing something simple, like you're writing a program, you're storing some data into a file, and you want to have like a timestamp whenever you store data in the file, just create new datetime now object and then output that in the file or so on. So instead of having your own tuples where you have days or dates or own variables for day and month and year or something like that, just use this datetime object because they make sure that you don't make any mistakes, like you don't create dates that don't exist, something like June 31st, which isn't a possible one. I think there are only 30 days in June, so if you want, let's see. So if I want try to create a date which is like 13th of February, what was that actually do? That's a good question. I think that shouldn't be possible, but it probably rolls it into. No, it is possible. That's pretty strange. Okay. Oh, sorry, forgot the date. Huh? Yeah, that's the reason why it was possible. So this one now gives us value error, that thing that day is out of range for a month. So if I accidentally try to create a date that's like 13th of February, which is of course a date that doesn't exist, then it gives us an error message, so I can fix or you can fix the program and then go on with that one. So instead of trying to do this by yourself manually, please use these datetime objects. Let's see if there's something, so you can compare the datetime objects, and you can roll time backwards or forwards by using the time delta objects. And yeah, and this formatting times is also useful. So when you have a datetime object, like the datetime now, and if you output it, you can see that it actually outputs the entire object with all the information. And a lot of time, when you're displaying information to the user, you probably don't want to display microseconds, for example. That's usually not important. And a lot of times you only want to display the date instead of time, or like a year and month or whatever. So for this one, there's this strftime method, which is the naming isn't like the easiest to remember, but it comes from, I think it comes from like string format time. And the idea is that you can now provide these special symbols in that string and these will be replaced with the specific values. So I can write something like it's year and percentage Y, and now it should display the current year, if I remember correctly. Was it capital Y or? Oh yeah. And again, these symbols, you're not supposed to remember these. You can Google this for easily. There are some listed in this table in here, like capital Y for year, lowercase d for day, and lowercase n for month. So if you want to use this like European standard, you can state that it's now some percentage d and percentage m, and then the year. So this gives you the date in this European form of having a date and month and year in that order. And let's see what. So hours are capital H and the minutes are capital M. So you can easily generate strings where you include these values from the datetime object. Makes it easier to display this for the user instead of displaying all those microseconds. And you can also easily change the format in which you use to display the dates, for example. Okay, I think that's it for the datetime object. Then a little bit about some of the other modules. I have a couple of examples. I think the first one is about reading CSV files. And now we talked about the CSV files last time, and we saw that it's not too complicated to manipulate CSV files ourselves. But there are some sort of problematic CSV files, and I created an example, or actually ChatGPT created this on my instructions. And this is a CSV file where in the first column we have a person's name, then we have a quote from that person, and then the person's age, and then their hometown as the final field, the final column. And the problem in this one is that there are commas. A comma is used as a delimiter, but there are also commas inside these quotes. And this means that if I just do something like this with open, and let's open the CSV example.csv as a file, and then for line in file, and then I try to pass this into a list. So do something like line dot strip dot split by using comma, and then I output the items. Then you can see that when we execute this one, there's a problem that, for example, if we take a look at this one, Alice Johnson line is Alice, and now there's now this quote is divided into two items. And this is problematic because, of course, we want this quote to be a single item, so that we can, for example, if we want to output all the quotes in this file or whatever we want to do, and so it doesn't work as intended. And the easiest way to deal with this is use the CSV module, which does it automatically. So we can import the CSV module. Then we create a reader from this module. and we provide the file, and then we provide the delimiter, which in this case is a comma. And then instead of iterating through the file, we can iterate through the reader. And now we can just, now this automatically generates lists for each line, that now when we execute this one, now each line is a list, and now you can see that the quote is a single item in that list. So using the CSV model is definitely the easiest way to deal with CSV modules. And it has some additional features like specifying formats for these columns and things like that. Now, if you take a look at this one, you can see, if you take a look at the file, that the first line in this file is this header line, and which is actually quite typical and actually quite useful as well. So you know that the first column is quote name, and the second one is quote, and so on. And the Visual Studio Code docs actually understand this as well. It displays like column 4 is hometown, and so on. But this can be problematic in a sense that if you want to handle the data, you probably don't need the header. And again, the easiest way to get rid of the header is just read it before creating the reader. So just get file.read line. Then we can have a comment stating that pass header. And now when we do this one, now we just have all the items containing the content, but don't have the header as a list. So we don't process the header like we process the content. So easiest way to skip header is just read it as a single line and then go on by reading the actual content. So you don't need to edit the file and get rid of the header. So CSV Reader is quite effective and quite simple to use. Also, again, a good example that you don't need to remember how it's used. Just Google for Python CSV model and you get a working example in a second, which you can then utilize in your own programs. That's how you're supposed to do things. You're not supposed to remember all the possible libraries or modules or anything like that and how they are used. Just learn how to use Google to look for the stuff. When you're doing these exercises, you of course have all the necessary information about the exercise usually, but when you're doing like real life programming. There's another example. It's actually also quite easy to read web pages by using Python. I'm not going to show you this one because I have restricted my Python installation can't access the internet at the moment for some reasons. I was doing some AI agent development and I needed to do some restrictions. But if you take a look at this one is again quite easy to adapt to your programs. There's this URL lib dot request a URL lib module, and there's this request class inside that one, and then there's that it one has a URL open method where you provide a web address, and then if you read that opened handle, you can get the web page as a text, as a single string, which you can then manipulate later. So you can specify any web address, any public web address here, and you can read the contents as a text. You can actually read images and things like that as well, but that's a bit more complicated. But if you have a resource in web, for example, and you want to use it in Python, you don't necessarily need to read it on your computer locally first, but you can read it directly from that web address. Okay, now creating modules is actually quite easy. So you can create your modules yourself, and you have all done this already. So the basic idea is that let's create a new file. Call it something like math.py. Let's do something else. It might be so boring. Doing like string operations.py, and then let's say that we have some functions for manipulating strings, like first word, where we provide a sentence as a string, and then it returns a string. And we can get the first word of a string, of course, by splitting it. And then by returning the first item in that list of words. Let's do something else. A function for calculating the vowels in a string, and let's say we have a list of vowels. To include y as well. There's some debate on whether, or some, it sort of depends on occasion whether y is considered a vowel in English, but we are going to do that. And then we can calculate the vowels in a string by iterating through the string. And let's return the number of vowels, and then let's of course call the list of vowels something like vowels instead of VOW. That's just lazy, and again, keeping your program as readable as possible is a virtue, something you should aim for. Even though I don't do it all the time, but just ignore my bad habits. So we have these two functions, and let's say that we want to reuse. Well, let's test them first, of course. Well, let's have a sentence. So Fox this morning, so let's try this one. Was it yesterday? So does it work? So yeah, it seems to be working. And also let's calculate the vowels of the same string to see if that one is working. It should be 1, 2, 3, 4, 10 seems to be correct. So let's say that I want to reuse these functions in another program. Let's say if you're writing these sort of tool-like functions which you want to use in your other program, and we can import this. What we have done effectively is that we have now created a module called string operations, meaning that if I want to import it here, I can just say that import string. Come on, give me some. Go. Import string operations, and now if I have a sentence, let's query one from a user. Calculate first. So we can call the function from the module we just imported. And see if it works in this other case. And then when we execute it here, let's give a sentence. And now it uses the implementation from this module. So this is again something that's quite handy. Oftentimes you write a code that's reusable in other programs. And if you remember, I said a while ago, I think at some point, or maybe I'm told it more than once, that whenever you're copying and pasting code when you're doing programming, it's a good idea to think that, is this something I can avoid? Is this something I can do in some other form? We know that we can use loops, so we can write functions and so on to reuse the same code like over and over again. And we can do it in other programs as well. So when we have this string operations module, we can import it into our other program by just importing string operations, and then we can use it like we use any module that comes in the Python standard library. So this makes reusing your code a lot easier. It also enables the fact that you can, when you have a longer program, you can divide it into different modules and then import those, or divide it into separate files, and then divide those, or then import those into another file, meaning that you don't need to have because it's typical when you're doing something more complicated that your programs can get really long. So it's a good idea to divide them into individual files, which are then easier to maintain, and then just use import to collect them all into one executable file. And of course, all the basic import things we talked about before work with this one as well. So if you want to state that from string operations import, and you just want to get the, what was the name of, why doesn't it give me any tooltips here? Calculate vowels like this, then this one works as well, and then you don't need to provide the module name if you want to. Let's just state that print calculate vowels, and abracadabra, not sure I wrote it correctly. It doesn't really matter, and then we can see that in there are 5 vowels in that one. So you can generate your own modules really easily. Here's another example, which that was actually. I remember that this one was about math operations, but yeah, it was about first word and last word, number of words or whatever, and then we can utilize it in other programs. And now something we've been talking about before. So let's return the test code in here. Okay, it wasn't here, but let's say that when we are writing this sort of module, but this program containing the first word and calculate vowels, we want to test them. So we see that they work, and also let's try to calculate vowels. And then when we execute this, we can see that they probably work as intended. We didn't break them anywhere. So, okay, this seems to be fine. And now the thing is that when I import this module, now what happens, take a look at the console. When I import it, now it executes the test code as well. And now this probably isn't what we want when we are executing it, when we are importing it into a different program. So we don't want to execute the test code ourselves, or in this occasion, but we still want to be able to write test code in here. And this is now where we are going to, why we are using the if name equals main thing. You've been using in those programs, and I promise that I will occasionally tell you, or at the end of the course, tell you why we are using this one. And the thing about this one is that when we use it like this, when I execute this program, it executes the test code as intended. But now when I import the string operations into this other Python program, it now doesn't execute the stuff inside this here. And what happens here is that this name with these 2 underscore characters in like before and after is a special variable which contains the name of the context where this is executed. So if I just output the name in here, that's a variable, you can output it. You're not supposed to change it, but you can actually change it as well. So now it displays main. And let's see. Let's output the value of variable name in here. Actually makes it easier to understand. So when I execute it here, it needs to be, of course, this main, because it executes the code in here. So the value is main. But when I import it, the value of the variable name changes, and now it becomes string operation. So now it's the name of the file. And this means that this variable has a different value depending on where the program is executed, whether it's executed directly or whether it's imported as a part of another program. And we can utilize this to check if we are running this module or running this program as is, or if we are importing it as a part of another program. And that means that we can have code that is only executed when we are running this here, like some kind of test code for these functions. But when we import it somewhere else, then we are not executing that code inside this block in here. And this is useful, especially in this kind of cases where you want to have a bunch of functions which you can import to another program, and then you also want to have some code in here that utilizes these these functions, but you don't want this code to be executed when you import it to another program. And this is the reason why we are using this in some of our exercises as well, because our test code, what it does, it imports your code as a part of that program, and then it tests the functions or whatever is written in the, depending on the exercise. And if some of the code is not included in this, then that provides like additional stuff that then messes up the test part. Okay. Any questions about these modules? I have some small things I want to talk about at the end before I say a couple of words about the exam. Well, let me know if you do. Okay, some useful techniques. There's this if else x or conditional expression in Python, which is useful if you have a case where there are two possible outcomes, like if else without any ellipse, and that results into a single value. So, and this has nothing to do with the modules. These are just some additional features. So let's say that we are querying the user for a value, a number. And you want to display if it's a negative number or not negative number, you can do something like this. This is a bad example. Let me just do it like this. And now we have a single expression which, as its value is, or evaluates into either negative or non-negative, or not negative, sorry. So if I provide a negative value, it displays that the number is negative. If I provide a non-negative value like a 0 or a positive value, it displays that the number is not negative. And this expression here evaluates into negative or not negative based on the value of this sub-expression here, like this if or this conditional expression here. You could write a parenthesis around this to make it maybe more readable. I think that's all sometimes useful, but you don't necessarily need them. Again, this is a technique you don't necessarily need to use. You can do like if statements like you've been using before. But this is sort of useful if you want to, for example, include this in the print statement. Now we just need to remember that you need to use different quotas because so we don't mess the print state or string above it, but something like this should work as well. So we can have a single expression inside the print statement, which is then evaluated into either of those strings. And this is, let's say, there are a lot of occasions where something like this can make your programs at least shorter and things. So let's have a list. Have a name list again. Something, let's see. And then let's say that we want to combine this into a single string. And now we can use the join method, but if for some reason we can't use it, we can do it like this. So for name in names, and then s equals s. Let's add the name, and then we add that like dot if name is the final name, and else we add and So what we come up with is a string containing all those names joined with and except. Oops. Let's just see where I'm going wrong. This maybe. We'll add some spaces as well. Oh, there. So now the parentheses are actually needed in this one to get the. So we get better Peter and Paul and Mary, and regardless of the number of items we have in this one. It generates a single string where there's an and between items, and after the final item there's a dot over there. This isn't this doesn't work in all possible occasions if there are, for example, duplicate items. But something like this might be useful and make your program a little bit. You can do this with a single expression, which might be what you need to do in some occasions. So you can't have like several lines of code, or it does make your program need a lot of external variables and things like that. But the basic idea is that you have a value if something is true, and else you have another value, and then this expression in here, we have dot if value is either into this value or this value, depending on this expression in here. So it's just like an alternative syntax for writing it in as a single expression instead of writing it as several statements or as an entire if statement. Then there's the pass keyword. We've been talking about this pass keyword before. The idea of the pass keyword or statement, it's not a keyword, it's a statement, is that it doesn't do anything. It does absolutely nothing, but it's useful because it is a statement that when you need to have an empty block. And something like this is useful, for example, when you start writing your program, you'll have like read data file and then you have like process data, and this is something you can do when you start writing a longer program, and you start designing your program, and especially if you have a bit longer program, it's easier to like find something like this as quite good method of designing your program is to start writing these functions, the name of these functions, and then when you're happy with the first version, then you can start implementing these one at a time. And it's like the way to design your program is to come up with these functions first and then start. And then you can use the pass statement here to create an empty function, because if you can't leave it empty like this is an error, because whenever you have a colon at the end of the line in Python, you need to have at least one indented statement after that one. So this one should work. Then something called, so let's say, let's see the open function, for example. We've been using the open function, something like with open, whatever names.txt. And then last time I mentioned something that when we use the open function, we can provide the write mode, or we can provide the encoding in here, or we can actually provide both. So what's the deal with the function that can have a varying number of parameters? Because when we write a function ourselves, something like this, then when we call it, we need to provide exactly 2 arguments. So we need to do this. If you try to provide a single argument for this one, it will be an error. Python will state that this type error getSum is missing one required positional argument B. So how can we do this? How is it possible that Python has functions that have varying number of parameters or arguments used when we call them? And we can do this by using something called default parameter values. So we can provide a value for a parameter in this definition line, in this function definition. And what this means is that we can now call this function and just provide a single value. What does the program? Well, it doesn't output anything, but what will the program output if I know how to spell read faster than I am? Yeah, it will output 15. And what it does, we provide 5 as a parameter value for parameter, or as an argument for parameter A, and then B uses the default value. How about this one? What does the program output now? Now it outputs 11. Yeah, exactly. And what it does in here is that if we have a case like this where we have a default parameter value, if we don't provide a value for that parameter, then Python uses the default value. If we provide a value as an argument, then that argument value overrides the default value. So we basically have like a parameter that has an initial value that can be overwritten when we call it. And if we don't provide a value for that parameter when we call it, then Python uses the default value instead. And this is useful when we have a function which a lot of times uses some default value, but sometimes we can provide like a value replacing that one, something like let's have a function that reads names from a file. So we open the file name in read mode. Have a list of names. Let's look at this. So now when we call this read names function, we can just provide the name of a file, something like names.txt, and it reads the list of names and returns them as a list. And now it removes the file name, removes the line feed from the end of its name, which is probably how we typically want to do it. Most of the time we want to get rid of them. But let's say that for some reason we want to keep them, we can then provide the value for this default value, which overrides the default value. And now when we execute it again, we now get the same list, but we have the after each name, there's the line feed. So for example, if you want to write some of these names into another file, it makes it easier later because there's the line feed already at the end, or whatever is the reason for this one. So default parameter values are great when most of the times you want to call the function in a certain way, but then sometimes you want to call the function so that you provide a different value for some of the parameters. Again, you don't necessarily need to use these. You can just provide all the values whenever you call them, but they are useful, especially when you have a lot of parameters in your function and you want to make calling it easier in some occasions. Okay, there are some more examples about this one, I think in the materials. Then the final thing for this course actually is the idea of having a changing number of parameters. And this is useful when you have a function which you call with lists a bunch of times. For the same example, sum of values. And now we can provide a single parameter, but let's have an asterisk before the parameter name. And now if you've been using languages like C or C++ before, then this asterisk doesn't mean the same thing than it does in those languages. It's this unpack operation in Python, and how it works is that now when we call the sum of values, we can provide a single value, like this. So what does the program output? Yeah, 10, because 10 is the sum of 10. But if we provide more values, and now we can just list the values here. We don't need to create any lists or tuples or anything like that. But if I provide more values, then Python automatically creates a tuple out of these and passes it in here, and then we can utilize it as a sequence. So we can get the sum, or we can do something like for value in values and output all the values one at a time. And again, we can call it with any number of arguments, and Python automatically creates a tuple out of those arguments and then passes it in here. And it is I think it is a tuple. Let me see if I'm wrong. I've been wrong before. But it is class tuple in this case. So Python automatically packs these arguments into a single tuple because of this asterisk here, and then you can unpack this in here. So that's makes again writing and calling some functions easier. Again, the main reason I'm mentioning this is well, this is useful. This is something you can use, but the main reason is that you encounter this in some Python programs, and in a lot of Python programs actually, and you need to know what the asterisk means in this case. Okay, then if you have any questions about any of these, let me know, because I'm going to say a couple of things about advanced course, which will start in 2 weeks. So remember, we don't have a lecture next week. Instead, we have an exam at next week. Is it next Tuesday, if I remember correctly? Just take a look at the course page. There are all the exam dates. What we're going to do in advanced course is for the first couple of weeks, we're going to concentrate on object-oriented programming. And what it means is that we are going to talk about something called classes and objects. And classes are ways to define like new ways or new object with new or our own. Well, maybe I can save this to advanced course because obviously can't summarize it in a single statement. But the idea of a class that we can combine data and the operations used to manipulate that data into a single, meaning that if you want to model a person, you can have all the data for the person, whatever it is, like a name and age or something like that, and then you have operations for manipulating that data, like changing the age or whatever. And then we talk about some other things, a little bit about functional programming, which is another programming paradigm. And then at the end, we're going to talk about game programming in Python by using this Pygame external library. It's really fun and rather simple way to create these 2D games. And then at the end of advanced course, you're going to program your own game. So there's a small project also included. Then about the exam, I'm going to show you an example question as well, but I'm not going to record it. So, but this one is going to be included in the recording yet. So the idea of the exam is going to last for 4 hours. If you have extra time allowed, it's 5. If you have extra time allowed, send me your certificate on that one before the exam. And the exam is open between 10 and 22, 10 in the morning and 22 in the evening. But the exam ends at 10 in the evening, meaning that if you want to spend 4 hours doing the exam, you need to start it at 6 o'clock at the latest. So regardless of what time you start the exam, it ends at 10 in the evening. Typically, there are coding tasks only. There can be some theoretical questions, but they usually isn't because it's a programming course, and what we're trying to do is to learn to program. 3 to 4 tasks typically. Nothing too complicated. I'll show you an example in a minute. The exercises are definitely going to be a lot easier than the most difficult exercises in the material. The whole idea of the exam is just to ensure that you know the basic things we were trying to do in here. They are assessed manually, and now as a sort of a warning, and I know this doesn't probably concern you, but it does concern some people. We take extra caution to find out if you have been using. You're not allowed to use any external help when you're doing the exam, and this also includes any AI tools. And we do pay a lot of attention in trying to figure out if you've been using them, and if you have used any legal tools when you have completed the exam, your exam result will be failed, and whether you can continue on whether you can retake the exam depends on not me, but on other people in university who are. I need to report this to them, and they will then decide on what will happen later. And if you try to use something like whatever ChatGPT in the exam, you probably will be caught. It's really likely. So don't do anything stupid. At this point, the exam is not supposed to be very difficult, and it won't be if you have completed most of the exercises. So don't worry about it too much. But remember that do the exam yourself, and you can use Google and you can use course materials and things like that in the exam as well. But you can't copy and paste code, and you can't use any AI tools for the exam. Okay, now I'm going to stop the recording.